Yes, Navneet, any challenge?
Yeah, it was not uploading. One second. I'm uploading it again.
Okay, you want to use upload option, not okay. You want to use IGC annotations, right?
Yes.
Yeah, it will upload. It may take time. More number of pages are there, na? So you converted in PDF, right? Before
Yes, yes.
uploading. Yeah. Yes. No issue.
Yeah. Good evening, guys. In this section, we'll be dealing aircraft climb performance. First, let me introduce about myself. I'm Navneet Krishnan, working as a senior UAV design engineer. I'm associated with GATE IIT's GATE classes since 2016, and I have been teaching this subject from 2011 onwards. We'll start with aircraft climb performance. Okay. If you see the force diagram for an airplane in flight is similar to this. If you see, there are four aerodynamic forces, four forces acting on an airplane. One is lift and drag are two aerodynamic forces which acts parallel and perpendicular to free stream velocity. Apart from that, there is one more forces acting is thrust, which always acts in the engine center line. Then, apart from that, weight, which is acting in perpendicularly downward. All these forces are acting at different points. Lift and drag acts about center of pressure. Thrust, we assume to be acting at aerodynamic center point. Then thrust, which is always acting at the engine center line. Weight will always act about CG. But since it's a force diagram representation, it all shown that it is acting about a single point. Because we are not taking any moment balance, we are only taking force balance equilibrium. That's why it is represented about a point. Okay. If you see this force diagram, this is the flight path direction. The angle between the horizontal axis, this is your horizontal axis. The angle between horizontal axis, and the flight path is angle theta, which is in most textbooks they are referred by an angle called as gamma, which is the climb angle. Then the angle between flight path and the chord line. What is chord line? The line joining leading edge and trailing edge of an aerofoil is called as chord line. The line joining leading edge, this is your leading edge of the aerofoil, this is the trailing edge of the aerofoil. The line joining leading edge and trailing edge is called as chord line. This is chord. So this is called as chord. Okay. So if you take the chord line, the angle between flight path and the chord line is called as angle of attack alpha. So thrust is acting at the engine center line. It is most cases, almost 99.9%, it is aligned with the flight path direction. But in some cases, it is slightly at an angle alpha t from the flight path. If you see, this is your flight path, that is your free stream velocity direction also. Parallel to the free stream velocity, there acts a component called as drag. Perpendicular to the free stream velocity, this is your free stream velocity, that is flight path direction. Perpendicular to the free stream velocity, there acts a lift. if you see here, weight is perpendicularly downward. So if we draw a line perpendicular to the flight path, what happens? It results like this. That is, it is parallel to the lift axis. So if we draw a line like this, so what happens? Weight is acting perpendicularly downward. So angle between flight path and the horizontal axis is theta, that is gamma. In most textbooks, they are referred it by gamma. In Anderson, they referred it by theta. Okay. So if I draw a line perpendicular to the horizontal axis, that is your this axis. This is your vertical axis, which is perpendicular to the horizontal axis. And if I draw a line, this is your vertical axis. Sorry, weight is acting in the vertical axis. If I draw a line perpendicular to the free stream velocity direction, that is your flight path direction, that is along this lift line. If this angle is gamma, then this angle is also gamma. Why? Because we drawn two perpendicular lines. The angle between two perpendicular lines of the same line will result in the same angle. So this is also gamma. Any diagram on force diagram representation of this airplane? Because if you understand this only, remaining every thing which I am going to derive is based on only this free body diagram. Any doubt? You can freely ask if you have any doubt. So every thing related to aircraft performance is based on this force diagram. Yes, Ravi, you have some doubt?
Asking to repeat gamma part.
Yeah. I'll repeat that. See, this is your horizontal axis. This is your horizontal axis.
Can you be little louder?
Yeah, okay. This is your horizontal axis. Okay, this is your horizontal axis. The angle between the horizontal axis and flight path is called as, this is your free stream velocity direction. Flight path is the free stream velocity direction also. So angle between flight path or free stream velocity and the horizontal axis is called as climb angle gamma. Is called as climb angle gamma. In Anderson, it is referred as theta. In all the other textbooks regarding this, it is represented by angle gamma. So what happened is, if I draw a perpendicular line to this flight path direction, which is your lift, this is your perpendicular to flight path direction, perpendicular to V infinity, flight path direction. And if I draw a line perpendicular to the horizontal axis, which is nothing but your weight is acting as perpendicular to the horizontal axis. So if the angle between these two is gamma, then the angle between the perpendicular lines is also gamma. Understood, Ravi? Ravi? The angle between flight path and the chord line of the wing is called as angle of attack alpha. Angle of attack alpha. Okay. So if you see this figure, the alpha plus gamma. Gamma is the climb angle, alpha is the angle of attack. So angle of attack plus climb angle is equal to beta, which is nothing but your pitch angle. Which is nothing but your pitch angle. So alpha plus gamma is nothing but beta, which is your pitch angle. In Anderson, it is referred, gamma is referred as theta. So alpha plus theta is nothing but beta. Beta is your pitch angle. Okay. Now we resolve this force diagram. So if I resolve parallel to free stream velocity direction, if I resolve all the forces parallel to free stream velocity direction, what happens? The parallel forces are thrust can be resolved as towards the angle is cos, away from the angle is sine. So it is going towards the angle. So thrust cos alpha t. First force resolved is thrust cos alpha t. Next, second force is drag. Drag is opposite to the flight path. So minus drag. And if you see this weight component, towards this angle it is W cos gamma, away from this angle is W sin gamma. So it is in the drag direction, so minus W sin gamma equal to mass into acceleration. Mass into acceleration. So this is the summation of forces parallel to free stream velocity direction. If I do the same summation of forces perpendicular to free stream velocity direction, what happens? First, there is a lift which is acting perpendicular to the free stream velocity direction. So lift. If I resolve thrust, what happens? It is away from the angle, so it becomes thrust sin alpha t, which is also in the same direction of lift. So it is plus thrust sin alpha t. Then if you resolve weight is towards this is W cos gamma, but it is opposite to the direction of lift, so it is minus W cos gamma. Perpendicular thing, so there is a centripetal acceleration, so mass into centripetal acceleration, mv square by rc, where rc is the radius of curvature. These are the force equilibrium equation based on this diagram. Any doubt on this equation? If you have any doubt on this equation, let me know, because based on this equation only we are going to get into climb performance.
Sir, repeat once more.
Okay. If you want, see, I am resolving these forces parallel and perpendicular to free stream velocity direction. That means parallel to flight and perpendicular to flight. If I see parallel to the flight, what are the forces acting? This is your flight path. So flight path is in the direction of V infinity. So if I resolve thrust, what happens? It resolves into two components, one towards the angle, one away from the angle. Towards the angle, it results in component called as cos. So thrust cos alpha t. Towards the angle is cos, so it is thrust cos alpha t. So one force. Since it is opposite to the direction of flight, drag, so there is a minus sign, so minus drag. If you see the weight resolves into two components, one is in this direction, one is in this direction. This direction, it is towards the angle, so it gives you W cos gamma. Here it is away from the angle, so it results in W sin gamma. But it is also opposite to the direction of flight, so there is a minus sign, W sin gamma. Mass into linear acceleration, normal acceleration. Okay. Then, if I resolve forces perpendicular to the flight path, perpendicular to the flight path only your lift is acting, so lift. Then if I resolve thrust, one resolves in this direction, which is thrust cos alpha t, other resolves in this direction, which is thrust sin alpha t, because it is away from the angle, it is thrust sin alpha t. Since it is in the same direction of lift, so there is a plus sign, plus thrust sin alpha t. Weight, it is opposite to the direction of lift, that's why there is a minus sign. So weight, when it is resolved in the lift axis, it becomes cos gamma. Weight into cos gamma. So weight cos gamma equal to mass into centripetal acceleration, because we are resolving forces perpendicular to free stream velocity. Mass into centripetal acceleration. Any doubt? Teja, you got clear?
Yes, sir.
I am taking these two equations as my reference to resolve to get climb performance equation. First, since we are studying about unaccelerated flight, climb performance is an unaccelerated flight performance. So both the acceleration will become zero. So my equation will become thrust cos alpha t minus drag minus w sin gamma equal to 0. Then lift minus w cos gamma plus thrust sin alpha t equal to 0, because acceleration has become 0. Okay. Because for unaccelerated flight, acceleration is 0. Alpha t is a very small angle. Generally, it is parallel to free stream velocity direction. So alpha t is 0. In most cases, alpha t is a 0, because it is parallel to the free stream velocity direction. If I take alpha t as 0 in these two equations, cos 0 will become 1, sin 0 will become 0. So I rearrange this equation. So it will become thrust minus drag minus w sin gamma equal to 0. Lift minus w cos gamma equal to 0. Because this part, what happened, it becomes 0. Sin 0 is 0. Okay. There are two equations. In this, first I'll start with the second equation. Second equation states that lift minus w cos gamma equal to 0. So it is nothing but lift equal to w cos gamma. So what is lift? CL into half rho v square s, called as lift, where CL is the lift coefficient. That is equal to w cos gamma. Now if I see, I'll take this equation again. So I'll divide throughout by weight. I'll divide throughout by weight. What happens? It will become lift by weight equal to cos gamma. We know lift by weight is nothing but load factor n. So lift by weight ratio is called as load factor. Okay. For climbing flight, the load factor will be always less than 1. N will be always less than 1 for a climbing flight. Why? Because cos gamma will be always less than 1. So if it is 90 degree, cos will become 0. If it is 0 degree, it will become 1. 1, it is for level flight, because gamma becomes 0 only during level flight. So cos 0 is 1. For level flight, the load factor is 1. Anything between 0 and 90 degree, the load factor results in less than 1. Okay. So for climbing flight, the load factor is less than 1. This is what outcome of second equation. Outcome of second equation is load factor is less than 1 for climbing flight. Any doubt? Okay. Then we'll move on. I'll take the first equation. First equation is thrust minus drag minus w sin gamma equal to 0. Thrust minus drag minus W sin gamma equal to 0. Okay. Now, I'll take W sin gamma on the other side. So it will become thrust minus drag equal to W sin gamma. I'll take the weight on the other side. So it will become thrust minus drag divided by weight equal to sin gamma. If I multiply by V infinity on both sides, if I multiply by V infinity on both sides, V infinity sin gamma is called as rate of climb. V infinity is sin gamma is called as rate of climb. It is also called as climbing speed. Okay. V infinity sin gamma is called as rate of climb. So this is nothing but thrust into velocity is power available. Drag into velocity is nothing but power required. Power available minus power required by weight is called as rate of climb. Or power available minus power required, we can rename it as excess power divided by weight is nothing but rate of climb. Okay. Thrust into velocity can be called as thrust power, drag into velocity called as drag power. Okay. Excess power divided by weight is called as rate of climb. Any doubt? If you see here, during climb, it started from an altitude h1 at a time t1. When it reached about this point, the altitude was h2 and the time was t2. And the time was t2. Okay. Now, the free stream velocity, when I resolve towards the towards the horizontal axis, it becomes v infinity cos gamma. Perpendicular to that, it will become v infinity sin gamma. Where v infinity cos gamma is the horizontal component of velocity, v infinity sin gamma is the perpendicular component of velocity. This perpendicular component is called as rate of climb. V infinity sin gamma is called as rate of climb. That rate of climb is change of altitude with respect to time. Okay. So, what is rate of climb? In some textbook, they represented rate of climb by v underscore v suffix c. It is nothing but dh by dt. Change of altitude with respect to time. So, it is total altitude gain for a given time. The total time we can call it as endurance. The total time we can call it as endurance. So rate of climb is nothing but h by endurance. Endurance is nothing but the time of flight during climb here. Time of flight during climb here. Okay. Any doubt? Condition for maximum rate of climb for a piston engine aircraft. So, first we take two classes of aircraft. One is piston engine aircraft. Piston engine aircraft, always performance parameters we talk in terms of power. Because only shaft power delivers you thrust. Shaft deliver, we have to rotate the shaft, then only the thrust is generated. So shaft power only delivers you thrust. So we always measure in terms of shaft power, that is power. Okay. So I already mentioned you what is rate of climb. Rate of climb is nothing but thrust into velocity minus drag into velocity divided by weight, which is nothing but power available minus power required by weight. For maximum rate of climb, for rate of climb to be maximum, once the engine is selected, power available is fixed. Once the engine is selected, power available is fixed. Power required, we can optimize it. So when power required is minimum, rate of climb is maximum. When power required is minimum, rate of climb is maximum. If power required minimum occurs at a condition where CL power 3 by 2 by CD max condition, which is nothing but CD naught equal to 1 by 3 CDI condition, where CD naught is the parasite drag, CDI is the induced drag coefficient. When we start from initial class, we will explain what is CD naught, what is CDI, everything will be derived actually. Okay. We will define what is power required minimum condition, we will derive the derivation for power required minimum condition, drag minimum condition, everything will be derived. Since we are starting with the climb performance, I am directly taking that equation CD naught equal to 1 by 3 CDI is the power required minimum condition. So when power required is minimum, rate of climb is maximum for a piston engine aircraft. Power required minimum occurs at a condition where CL power 3 by 2 by CD is maximum, which is nothing but CD naught equal to 1 by 3 CDI. Okay. Any doubt? Yes, Ravi Kumar. Ravi, do you have some doubt? Now, what is the condition of maximum rate of climb of a jet engine aircraft? For a jet engine aircraft, we never measure performance in terms of power. We always measure performance in terms of thrust. So, rate of climb is defined as thrust minus drag divided by weight into velocity. Into velocity. So I write this equation differently. Thrust by weight minus drag by weight into velocity. Free stream velocity. If I take lift equal to W cos gamma, lift equal to W cos gamma, your second equation. So lift is nothing but CL into half rho V square S. Weight cos gamma. So from this, we can write velocity, free stream velocity as V infinity as root of 2 into W cos gamma divided by 2 into W cos gamma divided by rho S CL. Since gamma is a very small angle, so it is always less than, most climbing flight performance will be always less than 15 degrees. So cos gamma can be taken as 1 itself. Okay, cos gamma can be taken as 1 itself. So when I take cos gamma as 1, so my equation becomes thrust by weight minus drag by weight into root of 2W by rho S CL. Okay. Root of 2W by rho S CL. In this, I'll take, since weight, density, and wing area is a fixed quantity if I take at a constant altitude. But during climbing flight, yeah, density slightly varies, but we always assume it is a negligible change. So we assume all these as a fixed quantities. Only thing during climbing flight changes is CL. So rate of climb is nothing but thrust by weight. If I take CL inside, it is CL power minus 1 by 2. Because if I take on the top, it will become CL power minus 1 by 2. If I multiply it inside, it will become thrust by weight, CL power minus 1 by 2 minus drag by weight into CL power minus 1 by 2, multiply it by root of 2W by rho s. Okay. Now, drag part can be written as drag is nothing but before writing drag part, yeah, we'll simplify it further. CL power minus 1 by 2. We know that lift is nothing but W cos gamma. We know that lift is nothing but W cos gamma. Okay. So, what is that? Weight can be written as lift by cos gamma. I told already cos gamma is a very small this one, so it can be written as lift itself. So, if I rewrite this, this will become drag by lift into CL power minus 1 by 2 into root of 2W by rho s. Okay. Drag is nothing but CD into half rho v square s. Drag is nothing but CD into half rho v square s. Lift is nothing but CL into half rho v square s. So if I divide drag by lift, it is nothing but CD by CL. So I am writing this, rearranging this equation. So it is nothing but rate of climb is thrust by weight CL power minus 1 by 2 minus CD by CL into CL power minus 1 by 2 into root of 2W by rho s. CD can be written as CD naught plus KCL square, where K is the induced coefficient factor. K is nothing but 1 divided by phi EAR. E for elliptical wing, it will become 1. Aspect ratio, it defines what is the length of the, what is the span of the aircraft. Okay. Where aspect ratio is nothing but B square by S. Where aspect ratio is nothing but B square by S. Where B is the span of the wing, S is the wing area. Now I substitute CD as CD naught plus KCL square in this equation. So my rate of will become thrust by weight CL power minus 1 by 2 minus CD naught plus KCL square by CL into CL power minus 1 by 2 into root of 2W by rho s. Okay. Now I multiply this inside throughout. Okay. So because for maximum rate of climb, we have to differentiate R by C with respect to CL, because CL is the only variable quantity. So if I differentiate with respect to CL, I will know what is the condition for maximum rate of climb. So thrust by weight into CL power minus 1 by 2, CD naught by CL. This is also, so if I take it minus CD naught into CL power minus 1 by 2. This is CL power minus 1. So this will become like this. CL power minus 1 by 2 minus 1. Then if I take the minus inside, so it will become minus KCl square. Already there is minus 1 by 2. So minus 1 by 2. Here CL power minus 1 is there because it is 1 by CL means CL power minus 1. So minus 1 into root of 2W by rho s. So what happens? If I rewrite this equation, it will become thrust by weight power CL power minus 1 by 2 minus CD naught into CL power minus 3 by 2, because minus 1 by 2 minus 1 will become minus 3 by 2 minus KCl square 2 minus 1 by 2, that will become 4 minus 4 by 2. So 2 minus 1, it will become 1. Okay, so it's what happens? This will become CL square 2 minus 1 by 2 minus 1. So 2 minus 1 is 1. 1 minus 1 by 2 is 1 by 2. CL power 1 by 2. Okay. Substitute CL power 1 by 2 into root of 2W by rho s. In order to get the condition for maximum rate of climb for a jet engine aircraft, if I differentiate this with respect to CL and equate it to 0, I'll get the condition for maximum rate of climb. You would have studied maxima minimum in mathematics. How you define maxima minima? If I differentiate and equate to 0, we'll get what is the condition for maximum or minimum. Okay. Same way, I am differentiating with respect to CL and equating it to 0. Okay. This is a constant quantity, so I keep like that only. Now, the constant quantity I'll put like so we are differentiating rate of climb with respect to CL. That is equal to root of 2W by rho s is a constant quantity. I leave it like that itself. Now, if I differentiate CL power minus 1 by 2 with respect to CL, what happens? Thrust by weight will become like that only. Minus 1 by 2 into CL power minus 1 by 2 minus 1. Okay. When I differentiate this, it will become like this. Minus 1 by 2 CL power minus 1 by 2 minus 1. Okay. Same way, if I differentiate this with respect to CL, what happens? Minus CD naught into minus 3 by 2 CL power minus 3 by 2 minus 1. Okay. Next, the last quantity. If I differentiate this with respect to CL, what happens? Minus K into 1 by 2 CL power 1 by 2 minus 1. That is equal to 0. So I can take this entire quantity root of 2W by rho s on the other side, so it will become 0 only. So if I rewrite this, so what happens? It will become is equal to 0 minus 1 by 2 into thrust by weight. CL power minus 1 by 2 minus 1 will become CL power minus 3 by 2. Minus into minus, it will become plus CD naught into 3 by 2. CL power minus 3 by 2 minus 1 will become CL power minus 5 by 2 minus 1 by 2 K. CL power 1 by 2 minus 1 will become CL power minus 1 by 2. Since everything is divided by 2, I'll take the 2 on the other side. So that becomes also 0. So my equation will become, I'll take minus sign also on the other side. So it will become thrust by weight into CL power minus 3 by 2. Okay. Plus, sorry, minus, because I am taking minus sign, I am multiplying it by minus sign. So this becomes minus, plus into minus will become minus. Minus 3 into CD naught into CL power minus 5 by 2. Because 2 I have taken on the other side, it has already become 0. Minus K into CL power minus 1 by 2. Since everything is in the power of minus, I throughout multiply it by CL power plus 5 by 2. I throughout multiply it by CL power 5 by 2. So what happens? If I multiply it by CL power 5 by 2, 5 minus 3 by 2. 5 minus 3 is 2. 2 by 2 will become 1. So this equation will become thrust by weight CL. Then if I multiply here, CL minus 5 by 2 plus 5 by 2. So CL power 0 it will become. Because minus 5 by 2 plus 5 by 2 will become 0. Anything power 0 is 1. So this totally will become 1. So it will become minus 3 CD naught. The last quantity. CL minus 1 by 2 plus 5 by 2. So it will become 5 minus 1 by 2. So 5 minus 1 is 4. 4 by 2 will become 1. 4 by 2 will become 2. So it is plus KCL square. That is equal to 0. This is the condition for maximum rate of climb for a jet engine aircraft. So what we can obtain from this condition is, substituting in this condition, we have to obtain what is the CL for maximum rate of climb. Then substitute that back in the first equation, thrust minus drag into velocity by weight. If I substitute that CL in that first equation, I'll get my corresponding maximum rate of climb for the jet engine aircraft. Any doubts? This is the condition for maximum rate of climb of a jet engine aircraft. Yes, Ravi Kumar. No doubt. Okay. Next, we'll derive the condition for maximum angle of climb during flight. So I'll take the first. What is that? Rate of climb is nothing but thrust into velocity minus drag into velocity divided by weight. What is rate of climb? It is nothing but V infinity sine gamma, the vertical component of velocity. V infinity I'll omit, so it will become thrust minus drag by weight is nothing but sine gamma. So gamma is nothing but sine inverse of thrust minus drag divided by weight. For gamma to be maximum, drag should be minimum. Drag minimum corresponds to L by D max condition, which is CD naught equal to CDI condition. CD naught equal to CDI. Your parasite drag coefficient is equal to induced drag coefficient. This is the condition for maximum rate of climb of a maximum angle of climb for any aircraft. This is the condition for maximum angle of climb for any aircraft. Yes, Ravi. You had some doubt?
Yes, Navneet sir.
Yeah.
Can you take up some question?
Yeah, I'm taking your thing right now.
Yeah. And one more thing, like you solve every step. We can keep some steps for students for simplification. Like we can tell always like one equation we write and we are differentiating with respect to particular quantity. They can do the middle steps, right? Otherwise, it takes for us, time, and for students, it's boring also sometimes. Yeah, please, sir, continue.
We'll see what is the effect of altitude on rate of climb and the effect of weight on rate of climb. Then we'll move on to some problems related to rate of climb. Okay. See, as altitude increases, in case of piston engine, what happens? The mass flow rate of air entering the engine decreases, so the power available decreases. So the power available decreases. This is at sea level, this is at an altitude. The dotted line is at an altitude. So as altitude increases, what happens? Power available decreases. Okay. When same way power required, as altitude increases, power required increases because drag increases, so power required increases. So what happens? Initially, this much excess power was there, but as altitude increases, the excess power got decreased. We know that rate of climb is nothing but excess power divided by weight. So since excess power decreases, rate of climb decreases. As altitude increases, rate of climb decreases. The outcome of this is the effect of altitude on rate of climb is as altitude increases, density decreases, thereby power available decreases, power required increases, thereby rate of climb increases. Sorry, thereby rate of climb decreases. Same thing happens for a jet engine aircraft. Okay, same thing happens for a jet engine aircraft. So what happens? As altitude increases, power available decreases because thrust decreases, because density decreases. Power required increases, thereby excess power decreases, thereby as excess power decreases, your rate of climb decreases. Both for jet engine and piston engine, as altitude increases, the rate of climb decreases. Okay. Next. What is the effect of weight on rate of climb? See, if you select an engine, it will produce some power only. We cannot change the engine power. So whatever the weight, that much only power is available. Okay. So engine can deliver you that much power only. So power available doesn't have any effect on weight of the aircraft. It only based on the engine selection you have selected. But as weight increases, your power required increases because what is power required? Power required is nothing but drag into velocity. Drag is nothing but CD naught into drag is nothing but CD into half rho v square. Drag is nothing but CD into half rho v square s into weight. We already know velocity is nothing but root of 2w by rho s cl. Velocity square is nothing but it is 2w by rho s cl. Okay. So CD into half rho v square. So what happens? Velocity term also contains weight. This also contains weight. So what happens? As weight increases, your power required increases in both the cases. For piston engine also, for jet engine also. As weight increases, power required increases. So initially, when there was W1 weight, the excess power was this much. As weight got increased, excess power got decreased in both the cases. So since weight increases, the excess power decreases. Thereby, rate of climb decreases. Okay. Any doubts? When we start from the scratch, how this graph is plotted itself will be telling you. Okay. How this graph is plotted itself we will understand. Then only we will come into this class. Okay. From first basic class, this how this graph is plotted, you will understand. Okay. Any doubt, Ravi? We'll see what is absolute ceiling and what is service ceiling. Then we'll move on to problems. As altitude keep on increases, see, it's just like a person being in his house. There is a roof. What happened? Yes, Ravi, you have some doubt. Ravi?
Sir, actually, this paper plan was the angle of sorry.
Your voice is
Angle of attack. Angle of attack.
Ravi, your voice is
Ravi, I think your voice is not clear. You can write in chat box.
your voice is not clear, Ravi.
Ravi, please write in chat first. Yes, Navneet sir, please.
What is absolute ceiling is? It's just like a person being in his home. For example, you have a roof. You are trying to jump in your house. What happens? When you are trying to jump, there is a roof over your head. So you cannot jump over that roof. Same thing for an aircraft. This is an absolute ceiling, is an imaginary ceiling above which the aircraft cannot climb. So what happens? No, angle of attack is different and climb is different. Angle of attack is the angle between flight path and your chord line. The angle of attack changes means that doesn't mean that you are changing your climb. Okay. Climb is nothing but, yeah, there will be rate of change of climb, absolutely. Why? Because you are going from one path direction to the other path direction. So since flight path is changed, then the angle of climb will be changed. That means you will have a different rate of climb. Ravi? What is absolute ceiling? Ceiling is nothing but the kind of roof. Okay, ceiling is the kind of roof. So if you try to jump in a room, what happens? There is a roof, so your head will smash on the roof. So you cannot jump over that. Same way, if we take in any practical aircraft, beyond that altitude, the aircraft cannot go. That is, there is no angle of climb possible. There is no rate of climb possible. Why? As altitude increases, I told you the power required increases, and power available keep on decreases. No, at one particular altitude, what happens is the power available curve just touches the power required curve. So it is just touching the power required curve. That means excess power becomes zero. That is, power available is equal to power required at only one particular velocity also. That is also at one particular velocity only. Power available is equal to power required. Remaining all the other velocities, power required is far greater than the power available. So you have to descend only. You cannot climb. So at one particular velocity, steady level flight is possible. Why? Because at that one particular velocity, steady level flight is possible. This is V infinity. Okay. At one particular velocity, steady level flight is possible. That beyond that velocity, there is not any, not even level flight is possible. Only descending flight is possible. Why? Because power required is greater than power available. So you have more drag compared to thrust. So you will be going downward. You will not be able to maintain that steady level flight also. So at absolute ceiling, what happens? Angle of climb is zero. Angle of climb, gamma is also zero, becomes zero. Rate of climb becomes zero. And power available just equal to power required at one particular velocity only. Remaining all velocities, power required will be far greater than power available. So beyond that altitude, that is the maximum altitude the aircraft can fly. But the time taken to achieve this altitude is infinite time. That means it is practically not possible to achieve that altitude at all, because due to wind, so many reasons are there. So because of that, you cannot achieve that altitude. So absolute ceiling is an imaginary altitude at which rate of climb is zero, angle of climb is zero. Beyond that altitude, the aircraft cannot climb. Okay? Any doubts? The last concept of this class. After this, post which we'll solve gate problems. What is service ceiling? What is service ceiling? Since absolute ceiling, that is absolute, it is also called as aerodynamic ceiling or absolute aerodynamic ceiling. Since that absolute ceiling is not achievable in flight because it takes infinite time to achieve that altitude, we define a practically possible maximum altitude the aircraft can fly. That is called as service ceiling. If you are 5 feet, you might be able to jump only up to certain height. If you are 6 feet, you might be able to jump at a different height. So, or a person with a different capability, he might be able to jump at a different height. So, same way, aircraft based on its power available, the aircraft can go up to certain altitude. So, the practically possible maximum altitude the aircraft can fly is called as service ceiling. For jet engine aircraft and piston engine aircraft, it defined as an altitude. First, I'll define for jet engine aircraft. For jet engine aircraft, service ceiling is taken as the altitude at which rate of climb is 500 feet per minute. That is, which is in meter per second, is 2.5 meter per second. If it is going below that speed, what happens? You have gone below if you have gone below this rate of climb, that means you have crossed the service ceiling altitude. So, which is dangerous for the aircraft. So, for jet engine aircraft, service ceiling is taken as the altitude at which rate of climb is 2.5 meters per second. For piston engine aircraft, service ceiling is taken as the altitude at which rate of climb is 100 feet per minute. Or it is 0.5 meter per second approximately. Okay. Okay. Next. What is the effect of weight on absolute ceiling and the service ceiling? So, I am trying to jump. I can go up to certain height. But if I take somebody else, like if I carry some weight or somebody else on my shoulder and try to jump, what happens? I can only jump to a lower altitude. Same way, for an aircraft also, if weight got increased, your absolute ceiling and service ceiling decreases because your power required increases. Thereby, absolute ceiling and service ceiling got decreases. That means for service ceiling for a jet and piston engine aircraft was this much. Let us assume for piston engine aircraft it was 0.5 meter per second. For jet engine aircraft was 2.5 meter second. And weight got increased, you would have achieved that service ceiling at this altitude itself. Why? Because you would have achieved that rate of climb at this altitude itself. So what happens is, as altitude increases, as weight increases, your both are the absolute ceiling and service ceiling decreases. Okay. Any doubt? Otherwise, we'll solve problems. Any doubt? Okay. We'll solve some three problems. Okay. GATE 2023, question number 59. An airplane with a wing platform area of 20 meters square and weight 8 kilonewton is flying straight and level with a speed of 100 meters per second. The total drag coefficient is 0.026 and their density is and the air density is 0.7 kilogram per meter cube. The total thrust required to introduce a steady climb angle of 0.1 radian is dash newton. Please try to solve. Then I'll solve this problem. I'll give a minute. You can solve. Try to solve. Otherwise, I'll solve this problem. Yes. There were two equations. What is that equation? Lift equal to W cos gamma for climbing flight. Other one was thrust minus drag equal to W sin gamma. Thrust equal to drag plus W sin gamma. This is the total thrust required to introduce a climb angle of this much radians. So we have to find out what is that. What is drag? Drag can be written as CD into half rho V square S. Weight, it is weight only. Sin gamma. Now CD, they are given it as the total drag coefficient is given as 0.026. So total drag coefficient is given as 0.026 into half. Density, they are given it as 0.7 kilogram per meter cube. So it is 0.7 kilogram per meter cube. The velocity at which it occurs is speed of 100 meter per second. So 100 meter per second. 100 square into S. Wing area, they are given it as, wing platform area is given it as 20 meters square. So it is 20 meters square. Plus weight, they are given it as 8 kilonewton, which is 8,000 newton. 8,000 newton. into sin gamma. Gamma is in radian. If you have a radian calculator, you can use that way. Otherwise, we have to convert that radian into degree. How will you convert? Multiply it by 180 by pi. So you can convert into degree. That is equal to, we get this value as 1820 plus 788.667. So it is 2618.667 Newton. They asked to round off to nearest integer. If I round off to nearest integer, this is 2619 Newton. Any doubt?
So, Navneet sir, you remember the same question we gave in our IGC mock exam?
Yes. Yes.
So
What
there
happened is
this
we have tried similar kind of problem in an IGC mock exam. We have given us
yes.
this one, but it was asked, not the values have been asked directly, but the problem procedure,
Exactly wording
whatever we
was
have solved, it has been asked same in the case.
yes.
Any doubt?
I think it seems no doubt. Next question.
Next question. Gate 2022, question number 18. The service ceiling of an airplane is the altitude. It's a select question, okay, single answer question. So we have to select which is the right answer. Okay. The service ceiling of the airplane is the altitude. Option A, at which maximum rate of climb is 100 meter per minute. Okay. Option B, beyond which theoretically the airplane cannot sustain level flight. Option C, at which maximum power is required for the flight. Option D, at which maximum rate of climb is 100 feet per minute. C, 100 meter per minute is nothing but 100 divided by 60. Okay. None of the aircraft, even piston or jet engine aircraft, is flying at this at service ceiling altitude. The rate of climb is this much. So this option is wrong. Okay. Because it is around 1.4. So none of the aircraft, not piston engine aircraft or jet engine aircraft, is having the rate of climb at the service ceiling. So this option is wrong. Option B, beyond which theoretically the airplane cannot sustain steady level flight. Beyond the aerodynamic ceiling, that is absolute ceiling altitude only, the aircraft cannot even sustain a level flight. So this option is also wrong. This is not the definition of service ceiling. Next, at which the maximum power is required for the flight. Beyond service ceiling, there is an absolute ceiling. Absolute ceiling only requires more power. At absolute ceiling only, power required is maximum. So this is also wrong option. So for service ceiling, the only option which can be correct is at which the maximum rate of climb is 100 feet per minute. 100 feet per minute or 0.5 meter per second, which corresponds to turboprop or piston prop aircraft. So option D is the correct answer. Okay. Any doubts? Yes. Surya, it's correct. Option D is the correct answer. Okay. Next. Question number, GATE 2019, question number 41. Consider an airplane with a weight of 8,000 Newton with a wing area of 16 meters square. Wing zero lift drag coefficient is 0.02. Ask for the efficiency factor of 0.8. Wing aspect ratio is 6. in steady level flight with the wing lift coefficient of 0.375. Consider the same flight speed and ambient density. The ratio of induced drag coefficient during steady level flight to that of the climb flight is dash. Please try to solve. I'll give the solution in a minute. Okay, how to solve this problem? Okay, I will solve this. How do you solve this problem? We want to find out what is the ratio of induced drag coefficient during level flight to that of the induced drag coefficient or the climb flight. Okay. First, to understand that, I have to know what is for level flight. Lift is nothing but lift level is weight. Lift is nothing but equal to weight for a level flight. A steady and level flight, lift is equal to weight. For climbing flight, lift is nothing but W cos gamma. So I can rewrite this as this is weight is nothing but lift of the level flight into cos gamma. So lift for climbing flight is nothing but lift of level flight into cos gamma. Okay. So what is CDI? CDI is nothing but CL square by pi ER for climbing flight, for level flight, sorry, because I'm replacing CDI of level flight. Same way, CDI for climbing flight is nothing but CL square by pi ER of climbing flight. That is equal to remaining all the other parameters same. Pi is same, E is same, aspect ratio is same. So it is getting cancelled. So it will become CL square for level flight divided by CL square for climbing flight. So that is nothing but lift of level flight divided by lift of climbing flight is nothing but 1 by cos gamma. Lift of level flight divided by lift of climbing flight is nothing but 1 divided by gamma, cos gamma, sorry, 1 divided by cos gamma. Lift is nothing but CL into half rho V square S. Lift is nothing but CL into half rho V square S. So this will become CL of level flight divided by CL of climbing flight. That is equal to 1 by cos gamma. Okay. Because half rho V square S divided by half rho V square S will get cancelled. So this will become CL of level divided by CL of climb is 1 by cos gamma. Here it is square. So 1 by cos square gamma. So what happens? What is the climb angle? They are given the climb angle of 30 degree. 1 divided by cos 30 the whole square. Okay. 1 divided by cos 30 the whole square. So it is nothing but 4 by 3. If I take round off to 2 decimal places, it is 1.33. 1.33.
So they gave so many data which are not used basically. It's a
Yeah.
simple.
So basically, when you write the correct equation, then only you will understand what is the data we need to use.
Yes.
Because in order to make you confused, they will give so many enormous data which might be useless for you. Okay.
So those
You
all
cannot
data
keep
for
on dragging what are the values given, why you cannot use.
Yes.
If you start solving the values, then you will get confused. Only we have to go by the basic concept.
Yes, and it is always good to simplify till end and then
Then
substitute.
use the data.
Yes. Otherwise, all this data for beauty of the question.
Otherwise, what
Person
you will
can-
do, no? You will start substituting for E,
Yeah.
AR,
Yes.
everything there. Then you will waste your time.
Yes.
So it is useless for you, because for any 1 mark question, you there is 65 questions, out of which there is 32 mark questions and 35 1 mark questions. Hardly you will have, basically for you have to solve this in 3 hours. Okay, 180 minutes. That means all the 100 marks you have to solve in 180 minutes. That means for 1 mark you have 1.18 minutes. Sorry, 1.8 minutes hardly. So for a 1 mark question, you can take only 1.8 minutes. For a 2 mark question, you can take up to 3.6 minutes. This is a 2 mark question. You cannot keep on drag the questions, solving them and putting values, everything. So you cannot hardly spend more than 3 minutes for any question for 2 mark question. For a 1 mark question, you cannot take more than 1.5 minutes to solve that problem, if you are attending all the 65 questions. Okay. For sub questions, you will be keep on dragging, so you will be wasting time. Known question also you will not be able to solve. So that should not be the case. Okay.
Yeah. So we do lot of emphasize actually no need to write gate paper in multiple rounds. I
Yes,
do a
correct.
lot of work on that because if we tell at least 3 rounds, they should do. So first easiest question, then middle level, and then at the end, and that
Yes,
too rigorous, mentoring we do, and that's how we always improve the result as best. Yeah. So you can take. I think we have done. We have solved
yeah.
questions also, and we
So
have told
any
all
doubt
the.
in this section?
We can take up now doubts. So guys, any
Any doubt?
doubts? Yeah, Khushi, Uday, Ravi, Shuryans, Teja, Kaustubh, Amit, Abhishek, any doubt? So one suggestion from my side, Navneet sir,
Yeah.
let's not do every steps when you simplify, these formulas. So
Yeah.
major steps you can write, remaining you can give ball in student's hand. So you can spend more time in solving question because we do lot of in that, right, and more time we can spend in physical explanation.
Yeah.
So yeah, sure. Any doubt, guys? So I think we have spent more than required, like half an hour more than what we have discussed. So guys, for any further clarification, doubt, you guys can reach us to on this number. You can write mail. You can visit our website. One more thing which I would like to showcase you guys, IGC's Telegram group. So if you guys see, IGC have uh, this Gate Aerospace Telegram group. You can see it's very active and two-way group. So if you share any doubt, any thing, we try to address. And you guys can see these are the IGC's daily quizzes. So that's one thing I thought to highlight.
Basically, in IGC, WhatsApp or Telegram group, what happens is students from any people will post a doubt. So most of the cases, students itself will solve the doubts.
Yes.
If it is not solved, what happens is the very next time the corresponding professor will answer all your doubts. If is any case, if he is not answering, the very next day you'll solve your doubt and you'll end up that doubt section.
So that's one about Telegram doubt forum, and uh, uh, one more thing you guys can always see is quizzes this, and I think yeah, postgate. I was telling about postgate guidance part, right? So you guys can go to IGC's YouTube channel and can see the kind of postgate guidance we provide. uh, uh, we have taken so many live sessions this year, you guys can see, for all different institutes. Okay, and we do not wait, you guys can see now. I hope, yeah. So many sessions we have taken. It can be useful to many of you. Okay, one is this preparation strategy session, or before that we also have taken the importance of gate exam. Okay, you guys can see many people have viewed this session. So like this, on our YouTube channel we are keep doing many activities, so you guys can always follow and utilize our work. So I think that's all from technical session. If you guys have any doubt, anything, you guys can ask. Otherwise, we will wind up. So any doubt or any concern who is watching this session on YouTube, I think it seems no. So we'll wind up. Thank you, Navneet sir, and
Yeah.
we will further improvise on our work and will provide best support to whoever join IGC. Yeah. So how was your experience, Suryans? See, this was just, glance of our work. We have not started from scratch. We have taken in between one topic and we have told like how we, approach a subject. Okay. In fact, deriving every step of, concepts and telling the physical applications and solving gate question. So that's how we work. Teja, any doubt?
Actually,
Yeah.
we go very basic. Why? Because there are non aerospace students also attend
Yes.
these classes. So we
Yes.
go very very basics. That means from what is aerofoil, what is chord length, we go to that range, and then only we derive all these equations. Since we are
Yes.
starting from the middle, it is like we have started a topic like directly.
Yes.
We will be going very basic and will be explaining why we have taken that, how that curve has arrived, and each point, any doubts will be addressed.
Yes. True. Yeah. So, guys, and again, one more thing. We will not take some toys and will explain. I have seen some video now, sir. Some people are taking aeroplane, some not toy aeroplane, and they are explaining. Suryans, see, we teach based on equations and graphs. Okay. So, no fantasy of learning, Navni sir. See,
No, no, he doesn't do that.
there is no use you show the toys and tell ki this is the chord, this is that. Those drama we are not going to do. Okay, so that's all from my side, and all the best, guys, and happy many of you have joined IGC. Some of you will enroll yet, batch has not been started. So all the best. Thank you, guys. Bye. Yeah,
Thank
Kushi,
you.
anything you want to ask, say? Yeah. Okay, then done, sir. Thank you, sir.
Good night. Thank you.